Hi, so today's video is going to relate to operations with fractions. Now, I know none of us like fractions, and we'd love to be able to just grab our calculator. But when we're in algebra, we have to be able to work with mental math. We have to be able to do mental math, and we actually have to be able to handle fractions. So in order to do that, we have to understand them. And we also have to understand the difference between adding and subtracting and multiplying and dividing them. And then that will lead us to handling them with as expressions versus equations. Okay, so let's look at this fraction, 3 over 2, 3 divided by 2, 3 halves, if you'd like to describe it like that. We need to know what the parts are. So the top's the numerator, the bottom's the denominator. I want you to think of the top as the amount we have, or the amount we count. The amount we have or the amount we count. Whereas the bottom is a description of how the whole or one has been divided. And that's why you heard me say 3 divided by 2. Okay, so it's describing how that whole or one has been divided, okay? All right, so let's look at an example of adding and subtracting. We have to remember that we will always need, when we add and subtract, we will always need a common denominator, okay? Because these are not like terms. Remember, like terms have to have the same number and variable. So because these have different denominators, they're not like terms. So the only way we can combine them is with a common denominator. Okay, so the common denominator in this case would be 35. So I have to multiply something to the left side and to the right side. But we're only actually allowed to multiply the number 1. So we do that by writing it as 5 over 5 because we want to get that common denominator of 35. And on this side, 7 over 7. Again, I'm allowed to do this because that is just the number 1. I'm kind of making the equations or the expressions bigger. All right, so that gives me 15 over 35 plus 7 over 35. Okay, now that the denominators are the same, we can actually simplify them. We can actually add them together, okay? So we combine. So we have to be really careful. We only add and subtract the numerators. We keep the denominator, okay? So this would be 15 plus 7 over 35, which gives me 22 over 35. And actually, I shouldn't use equals because it's an expression. I'm simplifying it. All right, so when we multiply fractions, this is different. Multiply, I want us to make sure that we cross-cancel first. I always say simplify before you multiply. Simplify before you multiply. And, some teachers don't like us saying cancel. It's really simplifying down to the number 1. But if I cross-simplify or cross-cancel, I'm basically saying that 5 goes into itself 1 time and 5 goes into 25 5 times. So I'm simplifying and seeing how many 5s go into 25. All right, and then 9 and 18, I can do the same thing. 9 goes into itself once and it goes into 18 2 times. Now that everything's simplified, you multiply across, okay? So that's going to give me 10 over 1, which is just 10. Now, I know we always want to write that 1, but if you have a whole number over 1, don't write it as 10 over 1. Write it as what it is, the whole number 10, okay? All right, let's practice a couple of it. Sometimes I can give you addition and subtraction, and there's variables as part of the denominator. Don't panic. It's the same thing. We need a common denominator. We need to make them like terms. So it looks like the common denominator is, let's see, 12a. Okay, 12a. So on this side, I need to multiply by 3 to get 12a. So I have to do 3 over 3. And on this side, I have to multiply. I need the a, and I need to make it 12. So 2a. So 2a over 2a. All right, so that's actually going to give me 21 over 12a minus 10a over 12a. Okay, so we've made them like terms, So now we can add them together. Again, let's make sure we remember we only add the numerators, we don't add the denominators when we're adding and subtracting. So that's going to give me 21 minus 10a. Why can't I say that that's, I don't know, 11a? Well, because 21 and 10 are not like terms. So you have to leave it as that expression, 21 minus 10a, all over 12. All right, what about fractions within fractions? You know, there's lots of ways you probably learned this in middle school. Sometimes kids say keep, change, flip, but I always find that you don't really understand what you're doing when you say that, okay? This is basically saying how many sixes go into 2/3, right? So when I think about dividing fractions within fractions, I'm very careful to understand like where the smaller fraction is. So I knew this bar is like the bar between them. That's the division bar. And so this is a fraction in the numerator. So this is the numerator and this is the denominator. And like I said, we're allowed to multiply anything by 1. All right, so I see that in this denominator, I have a 3, okay? So if I multiply both the top by 3 and the bottom by 3, I'm just multiplying by 1. Well, if I multiply 2/3 by 3, let me put it closer so you can see it. If I multiply it by 3, don't they cancel? So that gives me a 2 in the numerator, and then 6 times 3 gives me 18 in the denominator, which gives me 1/9. Same thing if I have a fraction in the denominator. I can multiply by the common, kind of think of it as like a lowest common denominator in some ways. So I'm going to multiply by y over y, okay? I'm just multiplying this expression by the number 1, which I'm allowed to do. So y times y gives me y squared, and in this denominator, the y's cancel, so that would give me over 5. All right, so hopefully you see another way to divide fractions within fractions. Even more challenging is when I put a fraction in the numerator and a fraction in the denominator. So we can use that same idea. Look at the denominators of both, find the lowest common denominator, the number that would simplify them, and multiply it as the number 1. So 5 and 3 have a common factor of 15, so I'm going to multiply this whole thing by 15 divided by 15. All right, so if I do that, 5 goes into 15 3 times. 3 times 3x gives me 9x. All right, on 8/3 x, 3 goes into 15 5 times and itself once. So then 8x times 5 is 40x. All right, we can simplify the x's, and so my answer would be, again, they're me using the equals and it's not, so 9/40. All right, so hopefully this has kind of helped you kind of look at fractions and simplifying them in a different way. All right, let's look at one more thing. Let's look at division, using the division symbol. I know I kind of jumped to, keep, change, flip. I know you had learned that, but let's talk about what division means. Like if I gave you 2/3 x, I don't know, equals 6. Well, what I see a lot of students doing is this. Well, that's just crazy because now that's given us this 6/2/3, right? Which is that fraction within fraction. You may have learned that what you can actually do is do the reciprocal, right? You could multiply this side by 3/2 and this side by 3/2. So dividing 6 by 2/3 is the same thing as multiplying 6 by the reciprocal, so 3/2. So then I can simplify and you'll get 9. So I think of that when I'm doing division. If I see that division bar, I have to remember that basically what I have to remember is that I can change it to multiplication by taking the reciprocal. And then I've got multiplication, so I can simplify. All right, so let's see what we got here. I have the a simplifying with an a. I have 5 going into itself once, into 15 3 times. Oh gosh, I have a 2 going into itself once and into 14 7 times. And I can cancel this b with one of these b's. So now being careful when I simplify that, it's going to give me 21 all over b. All right, well, there's plenty of places that you guys can find more videos on operations with fractions, but why not try the problems from your packets, see how you do, and kind of go back. But we are going to expect you to be able to work with both adding, subtracting, and multiplying and dividing fractions as you enter Algebra 2. Thanks so much. Have a great day.